Coming up on This Week in Radio Tech, Chuck Kelly is our guest. This is one of the smartest guys I know, but he's going to show us some technology that may be even smarter than him. Oh my goodness. It's the RF Supercomputer coming up next on TWiRT. This Week in Radio Tech is brought to you by Broadcasters General Store with outstanding service, savings, and support. Online at bgs.cc. By Angry Audio. Audio problems disappear when you get angry at angryaudio.com. And by Max Connect Wireless, prioritized high-speed internet service designed for transmitter sites and remote broadcasts. Hey, welcome into This Week in Radio Tech, the show where we talk about everything from the microphone to the light bulb at the top of the tower. And since I'm home for who knows how long, I just might get that tower light fixed, the one I've been promising for 5 years. No, longer than that. The one that's in the garage that needs to go right back here with a big red light on it. We'll get that fixed and have it here. I hope to do that. Hey, glad you're here watching This Week in Radio Tech. We've got a terrific episode for you. We're going to learn something together. We're going to learn about some new technology that is absolutely fascinating. The possibilities boggle the mind, and I'm really excited about it. So we're going to be talking to our guest here in just a minute. But right now, I'm in the Telos Alliance studio. Excuse me. In Nashville, Tennessee. Telos Alliance provides me with a little bit of time and a whole bunch of equipment around here to play with and to demo to people, you, broadcast engineers. So I appreciate coming to you from the Telos Alliance studio here in beautiful Nashville, Tennessee. The weather's cleared up. It's a gorgeous day. Almost feels like, well, it does feel like spring. The daffodils are out. And with all that, let's check in with Chris Tobin. Chris, are you okay wherever you are in place? Sheltering.
Yeah, I'm fine. I'm actually doing well. Things are not bad. The oxygen levels are back to normal. The contaminants, particulates in the air are down. We're good. No, things are good. I'm only kidding. Come on now.
Oh, gosh. What is that?
I have a little. That is actually, it's known as the 200SL.
Yeah.
There you go. It's basically a respirator faceplate. Allows you to get through a bad area. Smoky conditions. It's basically my high-rise building kit. It's what we use here at the transmitter site at the high-rise. We're in a transmitter facility. It's many, many stories above the city skyline, so in the event you have to evacuate under smoky conditions, that device is how you do it. Along with the goggles to keep your eyes...
protect your eyes, yeah.
So...
Can a device like that... Can a device like that filter air to the point of things that are creating a bad smell that they're filtered out, or do you still get bad smells?
I'm told it varies on the size of the smell molecule, but if you were to get crazy, but you can still smell certain things, but very, very, very light. I mean, it's very light. The two or three training classes I've taken over the years, it's interesting the tests they do, and you're like, I can barely smell it. You take the respirator off, you're like, whoa, hey, that's pretty strong, to demonstrate what it can do. So it's pretty cool.
Yeah. I guess the size of the particles that make smells probably vary widely, and they're probably very small. But I was thinking of one of the worst smells ever. Have you ever been to New Orleans in the summertime when it's sweltering heat and humidity? And the biggest problem that a restaurateur has in New Orleans is keeping the stench from the trash bins in the back of the restaurant from wafting around to the front of the restaurant. You got to keep that smell away.
You can experience that same smell here in New York City during the summer as well. Many restaurants in Restaurant Row have that problem.
Oh, man. Okay, so Chris, what time did we lose control of the show?
When I put the respirator on.
But there you go. That didn't take long at all. Hey, let's welcome our guest in here. He's been on before, and now he's got something to talk about. And Chuck always has some interesting technology, and I always learn something. This is what's great about being friends with Chuck Kelly. You learn things every time you rub elbows with him, which we're not doing today. You know why? So let's bring in our friend and mentor sometimes. That is Chuck Kelly. Hey, Chuck, welcome in.
Thank you, Kirk. It's great to be back.
It's good to see you here.
I'm in Indianapolis, Indiana, and the weather's almost as nice, but a bit cooler, but it's almost as nice as it apparently is in Nashville.
Are you calling Indy home these days?
Yep.
Ah, okay,
it's where my grandkids live. It's where my grandkids live, and that's where I decided that's where I need to be.
Oh, when I was a grandkid, my grandparents all lived in Indianapolis.
Mm-hmm.
Yeah.
Nice place. Yep.
Yeah. Been there many times. So, Chuck, give us a little preview. Wet our whistle for what we're going to talk about today, because I think it's fascinating.
We're going to talk about some technology that I call the RF Supercomputer. And I'm going to go through and explain, first off, why do we need something like this? And then how did we get to this point? And then what it is and what it can do. And I think you'll find it to be interesting. The whole idea, if you're familiar with SDRs, software-defined receivers, this is more or less an SDT, a software-defined transmitter.
Yeah. And what it can do, though, is you've even given me a little taste of what it can do, and it's not this isn't your grandpa's software-defined transmitter, is it?
Well, no, and it's interesting because it's really a product of the times. The bigger story here isn't a piece of hardware we've got, although that's a pretty cool story. The bigger story is, why do we need it? And what has changed in the world that made this technology unavoidable, really unavoidable? All
right. We'll be finding that out as the show continues.
Did I wet your whistle?
Yes, you did. Yes, you did.
Good.
That's good. Even better. And by the way, those of you, if you're listening, this show does include some slides that depict what's going on in the technology that Chuck is talking about. So if you can watch the show this time, be a good thing to do. Hey, but if you're driving along, if you're listening to the show, we'll try to make it all clear verbally as well. This Week in Radio Tech is brought to you in part by our friends at Angry Audio. And look at their newest product. It's well, this is part of it. This is a little antenna. Chris Tobin's going to help me out here. Chris, how much would you pay for this? We'll tell you what, let's attach it to something. Let's attach this little antenna to this guy right here. This is the new Bluetooth gadget, the Bluetooth audio gadget from the folks at Angry Audio. There's the Angry Audio logo right over there. And you see there's a cell phone with an emblem with it looks like a little 3.5 millimeter connector. I'll bet that's tip ring sleeve. And then it also has on it a BT pairing switch for Bluetooth pairing. And it has a connection, whether it's Bluetooth or wired. So if you want to use the little input plug there, you would use the input-output plug. You'd put it on wired. Otherwise, it'll be on Bluetooth. And that's what this antenna goes to. Now, why would you have a Bluetooth audio I/O device in your broadcast facility, in your radio station, or in your podcast studio? Well, I'll tell you why. More and more of our daily content, the things that we treasure and we love and we'd like to be able to share, more and more of that comes from where? Your phone, right? And so how do you get great audio out of your phone and into your phone? And how do you do that with maybe one talent after another coming through the studio? You really want a plug that's going to wear out? Or what if you have this phone that doesn't have any plug on it at all, at least not an audio plug? So what are you going to do? Well, Bluetooth is the answer. And the Bluetooth technology, over the years, Bluetooth has gotten better and better and better. I remember wearing Bluetooth headsets and refusing to wear them 10, 15 years ago because they were awful. But nowadays, Bluetooth can be really, really good at really high bit rates to connect, high quality codecs to connect, and even in a voice mode, the quality is better than the phone connection itself. So you put this in your studio, and by the way, it's under $400. So call your favorite dealer, go to the angryaudio.com website and look this thing up. This paired with your phone, let's say you just take a couple of phone calls per show. You don't really need a full-time telephone hybrid and phone lines. This device will help you out. Let's say you got some great music on your phone and you want to get into your audio console. Pair it up. You'll get great stereo audio through it to put on the air. Just amazing stuff that you can do with this Bluetooth audio gadget. This is from our friends at Angry Audio, angryaudio.com. And I got to remind you, they got Studio Hub. So if you buy some Studio Hub gear, ask for your free cable. You get a free Studio Hub Cat 5 cable just for asking your dealer for it. But you got to ask. It doesn't come automatically. You say, hey, I'm ordering a dozen adapters. I want my dozen cables. angryaudio.com. And I'm sorry, Suncast, go ahead and show that website again, especially with the Bluetooth device there. Go take a look at the new Bluetooth audio gadget. It's now shipping from angryaudio.com. Really cool. Thanks for sponsoring This Week in Radio Tech. All right, Chris Tobin and Chuck Kelly is with us. Chuck, I don't think we should fool around. You showed me this technology about a year ago, and I'm sure that things have moved along since then. So why don't you answer the question you asked? Why do we need this RF
Well, it's interesting because if you look at broadcasting in general, there are far more complex transmission modes than there's ever been. So if you think about ATSC, ATSC3, DVB-T, DVB-T2, ISDB-T, all these advanced digital transmission modes for television needed to be generated. And the way that we always did it in the past was purpose-built equipment. So they would take the standard and they would build up a system that does just that. And that's how it's worked since then. And it's been okay, but the problem is that the pace of technology is shifting faster and faster and faster. So a particular standard may only be a few years before it goes to something else. Yeah. There's another important thing, too, that's changed, and that is a focus on increased efficiency in transmitters. And in order to do that, in order to pull that off, they've had to use increasingly nonlinear PA stages. And those are far more efficient, but they're much worse for a digital signal. So the RF supercomputer, the exciters, have to be able to linearize an increasingly nonlinear PA stage.
Wow.
And okay. That includes things like Doherty, and not only is there first generation Doherty where you've got the primary amplifier, but you also have a peak amplifier, but now there's amplifiers that are like 4 stages of Doherty or 3 stages of Doherty. And the net effect of that is that efficiency in television transmitters has gone up from just a few years ago about 20%, the total PA efficiency, to over 60% in some cases.
What?
And that's been because
a 40-point increase in efficiency. Wow.
Exactly. And it's because of the linearization of the amplifiers and the increasingly nonlinear amplifiers themselves. So what's happening is just like we do in radio with adaptive pre-correction, where we bring back a signal that's a sample of the output, and then we pre-correct or pre-distort that in the exciter. Television exciters have been doing that for some time, and they actually do it 2 times. They do it at the output of the amplifier, and then they do it at the output of the bandpass filter as well, and correct for all of the deleterious effects that are occurring in those things. But in doing that, they end up taking the efficiency massively beyond whatever's been possible before. So not only are they greener, but they're saving a heck of a lot of money on electrical running power. And I can't vouch for what their actual motivation is, but it's good either way.
If I could put this in terms that I better understand, it sounds like you're saying that we can build amplifiers, and I'm talking about high power amplifiers, television signals, maybe an HPA for a satellite uplink, maybe FM transmitters, DAB, all these kind of. We can build amplifiers that are very efficient, but they become kind of not dirty, but they become nonlinear with these high efficiencies.
They become nonlinear.
And we can,
and they don't work anymore. They don't work anymore. The MBR gets too low.
Digital carriers anymore, but we can send them a signal that's not really the signal we want to transmit. But when after going through the amplifier's misbehaviors, but very efficient, we can end up at the far end with exactly what we want through a very efficient system. Is that what you're saying?
That's exactly right. What ends up happening is exactly that. You take a sample of the output, and you bring it back and you analyze it and you compare it with what would be mathematically ideal for the input signal. And whatever's different, you create coefficients that you go back and pre-distort the incoming signal so it doesn't cause those problems anymore.
So let me ask a theoretical question. I would think that some of these characteristics to a certain point you might already know, and you could build that into the algorithms that were in the RF generator itself. And then you've got to tweak, though, for the things that didn't match your model and bring that back and tweak it some more. Is it really kind of a couple stages like that?
It's more than that these days.
Oh.
Because things change. The temperature, the line voltage, the VSWR on the antenna, all of those things change enough that you can really see that difference. And you're not just correcting, for instance, for amplitude effects. You're correcting for phase effects. You're group delay. You're correcting for something called memory effect. These are all I mean, the amount of computational power that is required is unbelievable. So it's really kind of cool that just at a time when our industry needed this technology, computing power became possible that could allow us to take advantage of it.
You know what? I just figured out. Chris maybe back me up on this. So now here in Nashville, the recording studios don't use auto-tune because we have such great singers here. But out in LA, where the pretty people live, some artists do need to use some auto-tune in the studios, or maybe doing live performances. And so this is a bit like auto-tune. You give it and it's not quite right, and so you fix it, and it comes out great at the far end.
Yep, I think that's an accurate thing. So let's talk
Chris,
about.
Yeah,
go ahead.
I would say Chris and I are eager to learn. I need to shut up and let you start teaching.
Okay, no problem. I was just going to say, how did we get here? And Suncast, if you wouldn't mind throwing up the first slide, let's talk about the progress that got us to this point. So in 1964, the Philips organization started building their first analog modulators for television, and the PAL and the CCAM analog television systems. And then in 1999, they came out with a digital modulator. Now, it's interesting that the guy that's done all this in our organization is a fellow by the name of Morten Simonsen. He lives in Denmark, and he worked in all these years back in the Philips organization. Interestingly, while he was building digital modulators, there were people on other benches in the same laboratory coming up with MP3 and coming up with CDs. So it's really fascinating what a crux of a crucible of creativity was going on in the Netherlands back in those time frames. But as technology advanced, rather than having 10 DSPs in parallel in 1999, they came up with their own ASIC, which is basically designing a chip themselves. 2005, they came out with a third generation digital modulator where they came up with their own ASIC and FPGA. And just in the last few years, they came up with the Rf Supercomputer. And let's talk for a second about how that looks. Let's look at slide number 2. So this is a single PC card, and those connectors on the left-hand side, you see 4 Ethernet connectors, gigabit Ethernet connectors. You see 3 RF connectors. Those 3 RF connectors are RF out, and then the 2 sampling for nonlinear and linear sampling of the output signal coming back for a pre-correction. And then all the other connections on the right-hand side, and you can see the TCXO in the middle of the board. Let's take another shot, number 3. There's a close-up on how those connectors look. Each of those Ethernet connectors has their own network address. So they're all completely separate, and that gives you redundancy in things like that. So it makes it a much more redundant system. And the last shot is on the right, on the next slide 4. If you look at that closely, you can see how dense those components are. Just for fun for a second, for those of us that have built electronic equipment and troubleshot it, there's 2,200 individual components mounted on that 16-layer card.
Oh, my goodness.
Can you imagine? 2,200 components, and it's lunacy. I don't know how if you wanted to go in there and change R32, what are you going to do? What
this card is of a certain size. What does this fit into?
This fits into either a transmitter, or it can fit into a standalone cabinet that the company Pro Television also makes. Okay. But in a lot of cases, it's just a slide-in card in transmitters made by many companies, not just ours.
Oh, so this card doesn't have to be in a Broadcast Electronics Elenos transmitter. It could.
It's Elco. Nope. It can. Okay. It can be. In fact, is used inside many people's transmitters.
Now, early in our conversation, you mentioned ATSC, and then you mentioned ATSC3,
right.
And I'm not sure that we mentioned DAB, but there are other television standards as well all around the world. Are you saying that this supercomputer can be any of those?
Well, that's the magic of it. See, the hardware is fixed, but the software can be loaded into it. And as changes are made, I mean, I don't know if you realize how fluid the development of these television standards has been, but it's relatively fluid. There's bug fixes and there's changes that go on, and so this technology means you can go in and load a new load on there. And in fact, you can keep two separate loads on here. You could have a load on there for ATSC1, which is the current digital television standard that we're using, and you could flip a switch and you could be running the other half of the software load and run ATSC3.
Wow.
So that's the part that really makes it an RF supercomputer.
Okay, I'm digesting this, and I'm sure you've got a lot more. I want to ask Chris, who's up there with a bunch of transmitters right now. Chris, you got any comments or questions at this moment?
Well, no, I totally agree with Chuck. I mean, I've been playing with some SDR gear for RF spectrum measurements, and it's actually pretty cool, and also for demodulating FM signals from our friends. And it's your imagination is what pretty much holds you back. Because once it's in software or firmware, the hardware is designed one way. You know what the parameters are done. Then you work within that. It's great. I mean, where is it? Here, this is a 2-way land mobile radio, standard Motorola radio, and this is totally software defined in the UHF band, and the stuff that it can do in digital mode or analog. And it's just literally, as you pointed out, you just change a mode, and you're in ATS1, ATS3, or next gen TV, and then that radio could be analog to digital mobile radio, DMR. Oh, and they can coexist. So you can actually have 12 channels of DMR, 200 channels of analog, and just turn the knob. The radio changes automatically.
Oh,
so that's on the simplest terms, okay? But for what the TV technologies and what they're showing, what you're doing there, and downstairs is a TV transmitter that's digital and has some components that do the exact same thing. Some of the new stuff. Yeah, so it's pretty cool. I mean, I've been watching the guys put together. It's pretty neat.
And when you think about replicating what that little HT is doing in conventional technology that we all grew up in, you wouldn't fit it in a 19-inch rack.
That's right.
Okay,
wow. Chuck. Yeah, let's move on. Go ahead.
Okay, so I was going to talk about the next slide because the hardware is just part of the package. The magic of this thing is algorithms, and algorithms are a name or a phrase that denotes a program used to create a particular, in our case, a waveform, and so you end up with an algorithm. This one is a scrambler that takes data in, applies a process to it, and comes out with scrambled data, which tends in the transmission modes tends to create a decorrelation of the content and allows more bandwidth. I mean, one of the things that's really fascinating is that we are getting closer and closer and closer with these algorithms to the theoretical limit, which is called the Shannon limit, of how much data you can pack into a particular piece of bandwidth. And as you get closer to that Shannon limit, that theoretical limit, the amount of computational power it takes to do it just multiplies massively. Let's go to the next slide. Yeah. So that was a very simple algorithm. Here's a whole series of algorithms. This is actually ATSC3, and part of the ATSC process. I asked Morten Simonsen when I talked to him about this, how many lines of code is there in the ATSC3 code that you've written? Do you want to guess? 4 million lines of code.
Oh, man.
4 million lines of code. I just find it mind-boggling. Let's look at the next slide. This is the IP stack that's built in. So the IP stack is used for lots of things. It's used for bringing in the content, the programming, radio or television, having the user interface on the system. All those kinds of things are all part of the IP stack. And this is just part of all the pieces that are a part of that IP stack that's used on all 4 of those IP ports you saw.
Chuck, we don't have to go back to the previous slide. I will just talk for a second. Yep. I noticed, for example, that one of the blocks, and kind of in the middle of that slide that I said, oh my, you said 4 million lines of code, was something called Qualm Mapping. And earlier you talked about the decorrelation process that had to go on. Yep. And it seems like a certain amount of work is given to spreading data across carriers in such a way that they're all equally carrying some burden here, and as efficiently as possible carrying data that's, I'm sure, has got some redundancy built in there. It's got some interleaving in there, so that your receiver picks all this up. But if it decorrelates this and unmaps the Qualm modulation, that it ends up with exactly the data that it wants, and it's able to be error corrected should there be hits on that data. Is a fair amount of technology devoted to that?
Absolutely. But you hit on an important word, and that is efficiently transmitting. That's what all of this is about, is efficiently transmitting the data. If you look on an SDR or a spectrum analyzer at an analog radio station, you kind of see this bell-shaped curve kind of thing that is our station. Whether it's AM or FM doesn't make any difference. That's kind of what it looks like. But if you think about the bandwidth we're utilizing and then draw a box on that bandwidth, there's a lot of space that's not being used. Right. Now think about a digital carrier is an exact rectangle, because they're efficiently using all of that space to the maximum extent possible.
And if you think about, and I know plenty of engineers have seen this. I recently installed a Ubiquiti point-to-point link with some pretty new software, and it showed me the Qualm constellation, right? And if you think about it, you want to use every one of those symbols, and you'd love to use them all at the same time if you can, right? You want your data to be formatted such that you're using every possible method of transporting or representing a bit of data or a byte of data at the same time. If they're all there, you might as well use them. And so if you just put your data in and let it get carried, that really might not be very efficient, depending on the string of what your data is. But if you can map that data such that you're using everything, and that the other end's got to know instantaneously what that mapping was, then it can decorrelate. It can unmap that, do the correlation, and come up with a lot of data throughput, which is what we're looking for.
Well, that's what has caused all these changes. That's why we moved from an ATSC1 and we're moving to an ATSC3. That's why we went from DVB-T to DVB-T2, because we're getting more efficient transmission. We're using more tricks to pack more into that box.
Great. Let's see what's next.
Okay. This is the money slide right here. So this is showing the bits of hardware in the blue blocks on the left inside the big gray box. I'm going to try to define this for your audience that can't see this. Inside, we have a bunch of blocks, and we're showing the data flow from one to the other. In the upper left corner, we see an ARM microprocessor, which is called bare metal. It is actually programmed not in any operating system, but they're writing the code directly in machine language for maximum efficiency. But most importantly, they're writing it because it's deterministic. It is, the timing doesn't vary. The timing is what they call hard real time. Okay, so there's an ARM microprocessor in there that's written in machine language. And then there's another ARM microprocessor, but that's using an embedded Linux kernel. The TCPI stack, UI stack, and the user interface is all built into that. They communicate back and forth. The key pieces to this whole thing that make it really work is a TI DSP, digital signal processor from Texas Instruments, which again is programmed in what they call bare metal, which basically means machine language. And it communicates with an FPGA, a floating point graphics, or I think it's graphics array. Anyway,
field programmable
basically
gate array.
A program. That's it, gate array. It allows you to change it under programming. What it does under programming. There are 3 black arrows connecting those 3 bits. The DSP, the microprocessor from the ARM in Linux, and then the FPGA. That's shared memory. Okay, and the reason they use shared memory is a much, much faster way of transferring data among those blocks. Turns out that these various algorithms that are used in all these digital signal systems, these algorithms, each of them can be most efficiently created by different types of hardware. So some types of algorithms lend themselves well to an FPGA. Some types of algorithms lend themselves well to a DSP. Some types of algorithms can only be done under Linux, for instance. And so the key here is to break up all these simultaneous algorithms into the pieces that are most effectively done by the various parts of the RF supercomputer, to transfer the data as incredibly quickly as possible, and to keep it all synchronized. And that's really what the magic of this device is that ability to break all these. It's like parallel processing, but instead of parallel processing with 100 Raspberry Pis, you've got different types of Raspberry Pis that are attuned to different types of jobs, and you parse the project out to each of them.
Wow, that's like, you remember the guy on the Ed Sullivan Show that had the plates and they were spinning him with the dowels? You know, it feels like that. And you know, I work for the folks at the Telos Alliance, and I'm not a developer, not a programmer, not a hardware designer. I use the stuff, right? And I hear our guys talking about, you know, the real-time processes versus the non-real-time processes, and that's what you showed there. There are some things that don't have time for a CPU to run through a bunch of code and convert stuff, and it's, you know, like we type a web page or even play a video game, and that doesn't have to be quite real time. But when you're processing an audio signal, like an AOIP signal, or much more importantly, a video signal, there are things that got to be done real time. And as you said, it's coded to the bare metal.
Exactly.
Yeah.
Wow. One of the things that's fascinating is this RF supercomputer will run between 30 megahertz and 960 megahertz. So basically, the end result is we can create virtually any waveform from and put it in the RF bandwidth of 30 megahertz to 960 megahertz, I believe it is.
Wow. All right. Hey, we're going to take a quick break and come back. Chuck has more to explain, maybe including that last slide right there.
There you go.
He'll have more to explain. This Week in Radio Tech is brought to you in part by the folks at Broadcasters General Store in Ocala, Florida. I got the number memorized. It's 352-622-7700. Been dialing that number for years. You need to talk to them. And one thing you might want to talk to them about is this new product from Hank Landsberg at Henry Engineering. This is the new Superlight. Now, of course, you're familiar with the Super Relay. We've been using those for years. But what do we light up with those? We've been lighting up, 110 volt lights outside the studio door. Well, now so many lights are LED, and they don't need that big honking relay in there, and they don't need that noisy click, click, click. And they also, if you want to light an LED, well, what if you could just provide the power for it yourself? Well, check this out. The Henry Superlight is just, it's so convenient. I'm not going to say it's amazing. It's standard stuff inside, but the way Hank Landsberg has designed this thing to work in so many situations, it's got some jumpers inside. It comes with very clear directions. I read over the directions just before the show, and I thought, well, this is easy. Now, no matter if you've got, collector to ground output on a device, or you've got an actual relay closure, if you need to light an LED directly, or if, for example, you need to light something that has a higher voltage than an LED, you can still do it with the output on this. There's the directions right there from the website at henryeng.com. Check that out. And the Henry Superlight, if you do need dry contact closures, it's got those too. So if you need to, mute a ringer on a telephone, or if you need to, maybe, mute some speakers, or going to say start a cassette recorder. Isn't that silly? But you know what I mean? If you need an extra relay contact, you got 3 of those right here, and you got the LED light in the control. But here's something else. You've also got these Rj45 connectors. Now, these are not for Ethernet IP. They're very simple. They'll take a Cat5 cable, but this is for logic. So you can put logic wherever you want to between whatever 2 conductors that you want, and inside, there's some jumpers to pick that off. Hey, I want this box to close, to come on, to close, whatever, when wires number 7 and 8 have a closure on them or are hot with juice. And you can also loop this in and out. So let's say you've got one of these for each studio. You can daisy chain these together, and you can even program them differently. So there's a lot of wiring options to make your wiring simpler and smoother and less messy. Yeah. So check this thing out. It's from Henry Engineering, the Henry Engineering Superlight. It's an LED tally light controller from Hank Landsberg. You know, Hank makes good stuff. Check it out. Go to Broadcasters General Store in Ocala, Florida. Their website is bgs.cc. bgs.cc for Broadcasters General Store. Talk to Dave or Buck or Jessica or Carly or Jonathan. Anybody there will be glad to help you out. Thanks a lot to Broadcasters General Store for sponsoring This Week in Radio Tech. Chris Tobin and me, Kirk Harnack, were along today for episode 486 of This Week in Radio Tech. Chris, I'm not sure if we established very much. I was so interested in your accoutrements when you came on. Tell me about the facility that you're in right now. Or can you?
It's a facility that houses several FM stations, 2 TV stations at the moment, and many other land mobile operations that I can't speak about, but have helped to work on, and a few other digital facility things that are going on up here. A couple of ISPs that have been installed some stuff too. It's pretty cool. Matter of fact, I'm on an ISP's link right now. It's a microwave link, so I'm not even tethered to a T1 or fiber. It's some microwave linking between the city and some other pop they have, so it's pretty cool.
I think you mentioned the brand name of Shively behind you. What's some of the gear, the RF plumbing immediately behind you?
The plumbing behind me is there. I have this right. Constant impedance hybrid combiner, FM. So there are several FM stations combined here onto a master antenna on the rooftop. This is a backup site for several city stations, and it's pretty cool. I don't know if you can make it out because of the way they're designed. Let's see. It's hard to see it, but if you see that little handle there, see if this works. There we go. There's the handles. That's a filter. Actually, you know what? Hang on. Let's do it this way. Those guys in the foreground, those 1, 2, 3, 4 large, that's one filter. That's the older versions. The ones behind me are the newer versions, which are actually smaller. I don't know if you could see that, but that's what they look like.
Kind of stacked up. Is that to save space, or is that the way they have to be designed?
That's how it saves space, and that's how they work. They stack together. Yeah, I mean it's the same principles used in a combining system for a 2-way radio, digital, microwave, diplexers, all kinds of stuff. So it's just on a larger size because of the frequency. So, the lower the frequency, the larger the elements. Smaller the frequency, the smaller the elements. So that's what we have. So it's pretty cool. Yeah.
Awesome. All right.
Yeah. So I've been here all week, so it's been good.
Oh, you have. Wow. You're always interesting places. I like it. I like it when you go on the road and broadcast from high atop some buildings. All right, Chuck Kelly. He is the senior vice president for marketing at Broadcast Electronics / Elenos Group. And this is a combination of 2 terrific companies. Chuck, I wonder, could you spend just a second talking about this merger of these companies and what it means for the broadcast industry?
It's actually 4 different companies. Broadcast Electronics, of course, manufactures FM and AM transmitters and the Audio Vault system and own Marty. But then in addition to that, they were purchased by the Elenos Group. The Elenos is a manufacturer primarily of FM transmitters located in Ferrara, Italy. And they also bought a Telco, which is a long-term manufacturer of high-quality television transmitters in Orvieto, Italy. And then they bought Pro Television, this company up in Denmark that makes this RF supercomputer. And I was just absolutely flabbergasted with the opportunities, because once I mentioned the fact that it's got a very, very broad frequency range, and I'll clarify that's 30 megahertz to 760 megahertz in 1 hertz steps. But when you think about that, what it's capable of, it can work in radio. And that becomes very interesting. For instance, DAB is already implemented on this RF supercomputer. So we're already doing radio, but there is work going on, just FYI, there is work going on to bring it to other radio platforms that you and I know and love.
Wow. Yeah.
That's going to be very, very interesting.
So, let's get back to learning about this RF supercomputer. What's to explain next?
Okay, well, let's go back to that one slide we were looking at because we really didn't finish it up. There's on that slide in the lower left-hand corner is a block called timing and GPS, and they really call that GNSS in the world standard because it's not just GPS timing. It's also GLONASS, which I believe is a European standard. There's a Galileo standard, which I believe is perhaps Russian. I maybe have those two backwards. And there's BeiDou, which is a Chinese standard, I believe. So in each one of these situations, or each one of these systems, there are satellites orbiting the Earth, providing both timing and frequency, and the system is capable of monitoring all four, and you can set up a primary and a secondary. So if all of the GPS went down, you could switch over to GLONASS automatically and never miss a step. One of the things that's really cool is that timing block is very central to the entire device because every frequency on that device is generated from that timing reference. There are no clocks on this device that don't come from that. And that's important because, for instance, here's an extreme example. There is a very broad power range. You can feed this thing anything from 5 volts to 50 volts, and it'll run everything automatically. That means, if you're going to do it efficiently, that there's got to be some sort of PWM in there that is a variable voltage. And even that clock is derived from the GPS. And that means that there's no beating of the oscillators. It's all synchronous. The entire box is synchronous. It boggles the mind, the effort that went into designing this thing.
That's something, that I guess you have to think about. I didn't think about it. I was thinking, PDM typically free running, or there's a little loop that, hey, I need a higher voltage, I need a lower voltage, and the pulse width changes to fix that. But you're right.
Sure.
You don't want a little thing there just doing its own thing that may interfere with something elsewhere on the board. So
they're working so hard to make the quality perfect. They don't want it messed up by a free running oscillator.
There's some clever people behind this board.
There is. So it's fascinating to me, how much has gone into this. And one of the things that's really cool about this thing is suppose you had a television station, for instance, and you're running ATSC1. And you have had this television station using the RF supercomputer inside of it, doing ATSC1. And then eventually we switched to ATSC3 in this country. It's a software load for you. You don't have to go change the hardware. And you didn't pay for it. It wasn't even conceived of at the time you bought that transmitter. But you can go back. Okay, there's going to be some license fees. That's normal. But what the cool thing about this is this system can handle virtually any algorithm: DVB-T, DVB-T2, ATSC3, ISDBT, the Brazilian version of ISDBT, analog PAL, CCAM, NTSC, DAB, TDMB, DAB+, plus things we haven't thought of yet.
Oh, man. It's the beauty of standards, Chuck. There are so many of them.
I know it. I know exactly.
And apparently this RF supercomputer can do any of them. All right. Well, so we see that block diagram. We talked a little bit about real-time processes versus non-real-time processes. And then there were some blocks, the FPGA block in there. And then you got into the DAC and the ADC for bringing the samples back.
And the uptick version and all that stuff. And bringing those samples back, both the linear and the non-linear. It's fascinating the amount of, basically this thing is actually, I mentioned it's an SDT, but it's actually an SDT packaged with 2 SDRs. Because the two reverse paths are actually receivers.
Yeah. And they're critical so the SDT can do its job in this world of high efficiency, which ain't quite linear.
Exactly. Precisely right.
All
so
right.
there's another thing that's on this card too.
Yeah. Yeah. Go ahead.
Okay, there's another thing on this card. Let's go to the very last slide, not slash 9, which is the web interface, because none of this is very useful if you can't control it. So there is a built-in web interface, doesn't use any Flash or Java, and it allows you very easily to configure the system or change the system or even change to a different system. And you can download the software loads and upload them into the system even remotely. If you're one of these guys, work from home type of guys, you could actually do that. You could change from ATSC1 to ATSC3 by just simply uploading the new software into the system. I don't know if I'd play without a net like that, but you could do it theoretically.
I'd be a little nervous, but okay.
But all that's built into that same board as well, that web interface. And you can see, it's got a super good mimic panel. I can't walk you through it so well, but each of these green and red blocks you can actually drag down into the fields below and then make all the changes relative to that system.
Wow. Okay. Would a transmitter manufacturers, you mentioned that I guess these Pro Television cards certainly could be available in the Itelco brand transmitters, right?
And are.
Are.
They're standard. Yep.
And they're sold to others as well. And so I guess that web interface we just saw would become part of a larger transmitter's web interface for controlling all the other stuff in the transmitter. Exactly.
But when you think about a transmitter these days, most of the stuff you want to control is in the exciter or modulator, because that's where all the complexity is. Other than that, you're monitoring voltages and currents and temperatures and not much else.
So as not quite lay people, but as engineers who aren't quite used to the technology that you described, do you feel like we're kind of up on it now? I mean, have you taught us what you need to tell us about the possibilities here with this RF supercomputer?
I don't know that any of us know all the possibilities that it can do. It's a tool that we can utilize to create any waveform that we need in the broadcast field. And I'm teasing you a little bit about future developments, but there are some very, very exciting future developments for radio broadcasters that are going to come out of this, and you watch this space.
Oh, okay. All right. Well, I want to make sure we covered that completely before we kind of opened it up, Chuck, and
Sure.
and just did some freewheeling thought about the future of RF and where we see that going. Some people say, hey, in some number of years we really may not need broadcast transmitters anymore. Everything you want is going to be on 5G. Everything will be IP to your phone, or your device, or stuff in your house. And, sometimes I think that may be true, but sometimes I think, there's for a long time to come, there's going to be a place for broadcast, one-to-many transmissions, maybe with return paths through some means. Well, you're in an industry and you work for a company that's pretty forward-thinking. You're certainly talking to broadcasters and governments all over the world and standards committees. Would you like to spitball a little bit on what you see coming down the pike?
I think the most important thing that I can bring to answer that question comes from exactly what we as the world are facing today with this threat, the virus threat. And I think one of the things that we can also see is that the internet and social media are pretty easy with sending information out, true or not. I'm not taking a political stance in any fashion, but there are very few barriers to entry to getting a station on the internet that is blogging or pretending to be a news station, whatever. There are very few barriers to entry, and that means that they don't necessarily have to be 100% accurate. And I think one of the things that broadcasting, both television and radio, over the air, have as an advantage is they have a license, and they have a license that is issued in the public interest. And if they go completely off the left side or the right side, and don't give factual information, don't inform and educate people, they could lose their licenses. And I think that's a deterrent. I don't think all broadcasters are perfect all the time, but I think their believability, especially in times of crisis, is a very important thing. And I think that actually radio and television are going to be are potentially heroes in this critical time. And I don't mean just in the United States. I mean completely around the world. I think people will tend to turn to radio and television for accurate, believable, thoughtful information. And I think this is our challenge. This is our opportunity. This is our time to shine.
Well, I certainly agree with you there that broadcasters have a tradition of at least trying. And you know, that can be abused anywhere. I mean, think of state level broadcasts
Sure.
in undesirable regimes. You know, that they can transmit all kinds of fluff and nonsense. Here in the U.S. and in many other first world countries, we do have a tradition of at least trying to hold our head up and trying to say and do the right things. Doesn't always happen, but you know, we feel there's a burden of that public responsibility, probably more so than, you know, 100 years ago, 200 years ago, you could go to the town square and sell snake oil or talk about whatever you wanted to. And if people could ignore you, which they often did, or people could stand around and listen and buy what you're selling. Right. So we have the potential for much bigger audiences now. And you know, people are going to latch on to whether it's a snake oil salesman on the internet or in the town square. So you know, there will be a few that latch on to that.
Sure. I all I've ever, like you, my friend, all I've ever done in my entire life is radio, and I believe in it. I believe that free over-the-air broadcast, free over-the-air radio and television are so important to any kind of culture and economy and nation. And I think this particular challenge we're all facing can be made better because of radio.
Chris Tobin works right now at a radio station that, you know, specializes in not just entertainment, but an entertainment that I think is both soothing and inspiring to the human spirit, and that's jazz. Chris, would you like to pontificate for a sec on what we've been talking about here, and maybe as it relates to a station like yours, where you have live performers and you really get a feeling for not only the music but the people making it?
Absolutely. Well, I can echo what Chuck said actually about the impact radio has on broadcasters in general and what we can do in public interest. As a public nonprofit station, and during this time of crisis, we have been receiving a lot of emails in response to what we're doing, and people are grateful and they love the fact that they hear the music, and the music we play is soothing, it's comforting, it's something different, so you can get away from the chaos of the day, whether it's with the children, whether it's the job you're at, or maybe just getting back and forth to and from wherever. We've definitely have a lot of that, and plus our approach and content and educating and helping people is on many levels, not just with the music, but with community oriented material as well. So
that's right. You do
have that choice.
Yeah, you do a number of these broadcasts. Well, with with the mayor, and you do some things with the governor office.
Yeah,
there?
We do stuff with the mayor, the governor. We also do a lot with children's programming and jazz, introducing the younger audience, if you will, the farm team, I like to call it, to the genre, and say, hey, believe it or not, Bruno Mars may be your best song, artist that you enjoy, but he's influenced by the stuff we do. And here's a couple of tracks from his recent album that actually shows it. Here's an interview that he did on one of the entertainment shows and talks about it. So they're like, what? Once you open their eyes in that respect and give it the credibility as to, hey, yeah, what we do may sound like your parents' music, but believe it or not, it influences everyone in a very good way. And that's what we do. So we do a lot of the jazz children programs that we work with. So it's multi-tiered what we have. We have a lot of folks that come through the doors and a lot of things we're doing. So right now, with everybody being home and checking stuff online, our online stuff, the website, our videos, everything is spiking, if you will. And people are getting more exposed and have an opportunity to actually digest. And it's true for many other radio stations across the country. Anybody who's smart about what they do for a business model, this is the time to shine. Show what you do. Show it off. You don't have to spend $40 million marketing campaign to do it. Now it's just point them to the website, point them to whatever you have for your external communications. And I think you find it works out well.
I like what you say about introducing kids to jazz. I got to caution you, though. Introducing kids to jazz, you might not want to start with Miles Davis. I'm just saying that. I like starting kids at, kids love the Peanuts shows on TV. Introduce them to Vince Guaraldi first, right?
There you go.
And that's the happy music the kids like, and it makes me happy too. Miles Davis, maybe a little bit
There's
later.
plenty of artists in the jazz genre that we can introduce children to without any issues. Trust me. We've got Louis Armstrong and others we've done it with. Even more recent, Christian McBride, the bass player. You could definitely get some great stuff from him, and he's learned from some of the best masters there are. So, there's a lot of things going on that you don't realize. That's what we do.
Chuck, is there a jazz artist that you choose to listen to when you listen to jazz?
I like all four. My favorite group these days actually isn't jazz, but they border on it. Is Pentatonics. I absolutely love them. Been following them since the very beginning, and I sing in choirs, so a cappella music is my thing exactly. It's driving me nuts. Last night was supposed to be choir practice at church, and we're stuck home.
Same for me too. Did you see the post on social media of all those Nashville studio singers?
Yes, singing. I sent it out to a whole bunch of my friends. I did indeed.
Oh my goodness! So they all at home sang into their cell phones. I gotta believe some auto-tune may have been involved, but these are all professional singers. Wow, that was pretty amazing. We'll link that in the show notes. Hey, Chuck, we're almost out of time. We're going to do a quick mention of a terrific sponsor, and think of our the tip of the day that you'd like to tip of the week that you'd like to leave people with. Our show This Week in Radio Tech is brought to you in part by my friends at Max Connect. And Chris, I'm going to ask Chris to chime in on this box. The Max Connect is not your ordinary data modem that talks to 4G towers and services. No, it's not ordinary, because you know what? You can go out and buy a Cradle Point router just like this one, and you can go to AT&T or Verizon or T-Mobile or Sprint and get you a data card, but we will not get the service that you get from Max Connect. Why? Because yours won't be prioritized. You'll get the same service as everybody else around you who's checking their Facebook or whatever, playing words with friends. Is that still a thing? But if you get one of these from Max Connect Wireless, you're a broadcast engineer. You want every packet to get through. You want your audio or your video to be good. Max Connect Wireless will do it. The reason is that your packets are prioritized over all those other schmucks all around you who are on their cell phones. You get a higher priority packet than anybody except for first responders. And Chris invited me out to go to a remote broadcast with our buddy Sam. And Chris, what can you add to the reliability that these things offer for broadcasters?
I'll preface it with, you're not going to get the highest bandwidth if the cell site doesn't offer it, but you'll get whatever bandwidth they're giving you and hold on to it. That's how the prioritization works as well. So one thing I've learned working with this Max Connect product and working with the cellular technicians to find out more about how I move around my areas is that the cell site, put it this way, your Max Connect connection, the radio link from that box to the cell site, is definitely the highest speed you're ever going to get within Shannon's law. But the cell site itself has issues when it comes to bandwidth, and that's up to the cell company. So the good thing is you get the bandwidth second. Public safety, you, then everybody else. So if the bandwidth at the facility, at the cell site is, 2 gigs, 100 gig, and for some reason it gets loaded down, those that are at the highest top tier, you stick with what you have. If you had 100 megabits back and forth, you most likely will keep it. Everybody else, it'll drop. And that's how it works. It's prioritized. It's like running a VLAN or running a QoS on your managed switches at the office. You dictate what ports have what bandwidth and who's going to get what. That's how this works, and it does work. And yes, the show that I work with, the sports program from a sports bar, we've done many successful broadcasts, netcasts. That is, it's a network, it's a net show, podcast show with the Max Connect, and it's worked out well. As a matter of fact, I know he has been using it on the road from his car on many occasions, not only here in the New York City area, but in, I think, North Carolina and Florida recently. covering all hockey-related stuff, and it works.
I've seen Sam posting from the road. Ours is set up for 5 megabits. We do get 5 megabits up and down, no more, no less. And I'm not saying every packet gets through. I don't know, but we've done video and audio with these. You're doing video or audio. You're doing a live remote broadcast from somewhere, or even a emergency backup to your transmitter site. Lots of your big broadcasters are getting these. Getting that monthly service because they know that it'll keep them on the air and let them do broadcasts from places they never could do it before. Max Connect Wireless, check them out. There's the website. It's spelled funny. I'll put the link in the show notes, maxconnectwireless.com, and it works with all your favorite carriers. So mine's set up for AT&T and Verizon. It's a service from Josh Bone at Bone Broadcast. All right, This Week in Radio Tech is about to wrap up, but very importantly, Chuck Kelly, I know I surprised you. But can you come up with a tip of the week? Something we just can't do without. Good.
Chris brought it up. He mentioned SDRs and the fact that he's learned a lot by goofing around with SDRs. One of the things that I think all three of us probably do, I know I do, is we mentor through the SBE mentoring program. The question I get asked most by these mentees is, how do I learn the RF side of things? I know IP, I know audio, I don't know how to do RF. SDRs will teach you a heck of a lot about RF. For $100 or $150, you can get an SDRplay. It goes from DC to purple. You can see everything like on a spectrum analyzer on your screen, demodulate any kind of waveform, see what happens, see what a station looks like with HD or a TV signal. All of that stuff is easy, and you'll never find an easier way to learn RF. That's my tip of the week.
That's a great idea. I've learned a lot by looking at a little cheap, $25 SDR and the software that you can download. That's awesome. Do you have a favorite SDR for receiving?
SDRplay.
Okay.
SDRplay.
Right.
You can put the link in the notes. Not expensive. Goes from DC to purple. It's really good. It's really good.
All right. Well, I'm going to ask Chris if he's got a tip of the week, and it might be, don't touch the hot RF output. Chris, you got anything for us?
Yes, keep your fingers away from the coils on the transmitter when it's generating a signal. That little burn that goes from inside out does hurt. I've had that happen too many times. No, my tip of the week was, given the conditions we're operating under for broadcast, both television and radio, look at different ways to do your remote locations, your announcers on site, or whatever you may have to do. Don't forget, USB microphones do work very well. So if you've got to keep the parts count down, USB mics, even small HD cameras that are USB can work very well. Just make sure you have a good, powerful laptop that you're working with. I'm doing it right now with some of our announcers with USB mics so they can voice track into our system and be at home and still produce what everybody loves listening to. So that's my tip. Look at things differently. Don't use the same old setup. You're in panic mode, like, oh my God, I got to get a mixer, I got to get a microphone, I got to get. USB products actually do work well. Just think it out. That's all.
You are so right about that. Thanks for that tip. And it's we engineers are helping plenty of broadcasters or talent go on the air from home. USB mic is really good idea. I was talking to Andrew Zarian earlier today about that Audio Technica AT was it 2005 USB. Is that it? That one is just I'll put that in the show notes as long as I got the number right. What's that, Suncast? Okay. Cool. I'll put that in the show notes too. Thanks for the tip. Appreciate that. My own tip is that I did it again today. Very few people are at our radio stations, and one of our salespeople was in the office, and the printer hadn't worked apparently in 2 days. And they got the print. It's one of these big honking printers we have a trade for. And the printer guy came over, and he said, "Well, you got a problem with your IP address. There's something blocking your IP." Well, it's on the LAN. There's nothing blocking the IP. So he left, telling the poor sales lady to call your engineer and have him unblock that IP. There's nothing blocked on the LAN from one computer to another. So anyway, after trying for a while to troubleshoot this just with a phone conversation, let's do a FaceTime. Let's just do a FaceTime, Beth. And so we did a FaceTime and solved that problem in about 2 minutes. We had a little switch in the office that feeds a computer, a VoIP phone, and the expensive printer. And for whatever reason, one of the ports on the little cheap Ethernet switch that was on her desk, one of those ports had quit working. The link light would come on, but no data would pass. So there's an empty port next to it. Let's just move it over. So yeah, we moved it over. And by the way, just talking about the colors of the wires and ports, and that wasn't working. We were getting nowhere in terms of discussing this. So got on the FaceTime, bam, 2 minutes later, she plugs it in. All of a sudden, oh my gosh, the printer's printing stuff, lots of stuff. So all those print jobs in computers around the building. So my tip of the week, FaceTime. And if you got to talk to somebody who has an Android, there's the Duo. That program lets you talk with the camera. And there's a Duo app for your iOS device too. So there you go. That's my tip. Anybody got any last things to say before we go?
No, just have fun with SDRplay.
Really enjoyed it. Oh, there you go.
Good deal. I'll make sure SDRplay gets a shot in the show notes. Hey, thank you for watching This Week in Radio Tech. Thanks very much to Chuck Kelly. Chuck, let's say goodbye. Good to see your face and hear your voice. We get
Good
Chuck
to see you, and thank you again.
Okay, all right, and thank you, Chris Tobin from some RF cage on the top of a building somewhere in Manhattan. Please be careful. Good luck to you, and have your papers when you go home. Have your papers when you go home.
I have my paperwork with me. Trust me, and my 12 IDs and everything else. So I'm good.
I talked to Ed Bucant yesterday. He was driving home from the D.C. area back to Tennessee, and I said, Ed, do you have your papers, your authorization from DHS? He says, oh, yeah. He says, I got a binder full of them. I know these federal rules. I got all kinds of stuff. You wouldn't believe what I can buy. All right. Hey, we got to go. Thanks a lot, Suncast, our producer for this show. Thanks again to Chuck Kelly and to Chris Tobin. Thanks to Andrew Zarian, the founder of the GFQ Network. Tell your friends about This Week in Radio Tech. We have this fun and do this every week. We got some great shows coming up, including what you won't see at NAB and what you didn't see at NAB. That's coming up in the middle of April. We'll see you next week on This Week in Radio Tech. Bye-bye.